In this video we're going to explore the new Sail Join Edge Style tool introduced in version 14 of MPSD. MPSD was designed to make patterns for sails of 3 to 6 sides. Some users work around this limit by creating multiple patterns with fixed edges selected to join the sails on the factory floor to make sails with more than 6 sides. While this has always been possible, MPSD sets the corner links for fixed edges to a length of 0, assuming the sail edge is connected to the wall. This means sails joined using fixed edges as a workaround need to be manually modified to allow for sail connection links such as turnbuckles. The new Sail Join Edge style facilitates this workaround by allowing the inclusion of corner links which can be added to the sail join edges. We'll demonstrate this feature with a few different sail shapes to learn how models are created and better understand how it works and, most importantly, its limitations. Let's start with a simple 5-sided sail. Viewed in CAD, we can see the natural shape the fabric would take for a 5-sided sail with 4 posts at the same height and 1 low post. We can see the fabric curves down between these 2 posts as a result of the tension created by the fabric being pulled down to the lower connection point. We'll now make the same shape in MPSD by joining a 4-sided and a 3-sided sail together. This is purely for demonstration purposes, as MPSD can already handle a 5-sided sail without using this workaround. Using the regular shape option, we'll make a simple flat 4-sided sail and set the edge B to C to be a sail join. When we calculate the model, we see a new message pop up in MPSD warning that the sail joins are created as straight lines between connection posts, which may not be the desired shape. If it's okay, then click Yes to continue. We can now see the shape of the left half of the sail in the Visualization tab and can clearly see the right join edge is a straight line. For the right half of the sail, we set the A to C side as a joined edge, and again in the Visualization tab we can clearly see the join edge is a straight line. We previously exported both models, so we can now view them in CAD. Here are the 2 separate parts, then the 2 parts joined together. Now we can place the new joined model on top of the original green 5-sided sail model, and we can see the difference in the shapes. The green sail is the correct natural fabric form with a smooth dip between these posts, but the new 2-part white sail has a straight line join between the same posts. Now let's look at the difference in the actual patterns which are produced from both the green and the white sails. The green patterns show a gap of 111 millimeters, about 4.5 inches, between the 2 parts, which is a slice out of the final join panel to create the 3-dimensional form. The blue panels from the white sail, on the other hand, have no gap between the 2 parts. When we superimpose the 2 sets of patterns on top of each other, we can see 2 differences. Firstly, between the posts we can see the green patterns are slightly bigger, allowing for the extra arc length required for the fabric to dip down between the posts. Secondly, on the right, we can see the blue pattern is slightly bigger, reflecting the extra length in the fabric, which is flat from the left half and then slopes down from the straight join edge to the low post on the right. These differences may be small and can be accounted for provided sufficient allowance is made for corner link lengths, such as turnbuckles. If, for example, this sail were made using a joined edge tool and it was to be connected with direct shackle connections on these 3 posts, we can see the sail could be too big and therefore loose if the link lengths were not adjusted correctly. Another area where the straight join edge between posts can present a problem is for sails with uneven edge lengths. In this example, we've joined a large 6-sided sail on the left with a smaller 4-sided sail on the right. As a result, the corner link angle, let's say it's a turnbuckle, can swing a little towards the bigger half of the sail for a webbing edge or individual cable edge sails with the same dip-span ratios. Also, we can see a smooth curved shape between the posts, reflecting the correct force-balanced fabric form. Making the same sail using MPSD and the Sail Join tool produces a model form with a straight line join between the 6-sided and 4-sided sails, and the link angles are also in a straight line. When we superimpose these patterns on top of each other, we can see a 50mm, 2-inch difference in position in the sail corner where the 2 sails join. Once again, this should be taken into consideration when using the Join Sail tool. The larger the difference in edge length between connecting sails, the larger will be this discrepancy. This situation only applies when using webbing edge or individual cable edges with the same dip-span ratios. It will not arise when using a single cable with easy slides or slip ring type corners. Thank you for watching. For more information, please contact support@mpanel.com.